Welcome, everyone, to the Building Smart USA July 2024 webinar. Today, the topic is openBIM-based estimating. And the reason you see that it's an update is this is an update to a presentation that Brent did a year and a half ago about openBIM-based estimating. And we were just saying before the beginning of this presentation how amazing it is that so much has happened over the past year and a half. So Brent will be joined today by Alexander, who's with BEXEL. They will take turns to show the work that they've been doing, Brent's work with Beck Group and Alexander's work with BEXEL. We think that you'll be thrilled by all the advancement that's taken place, and certainly we thank both Brent and Alexander for being here today. Veljko is sending his regrets. He is currently in a location without sufficient internet connection to do the video. However, the material that he would present will be picked up by Alexander. So without further ado or delay, let's turn it over to Brent. And Brent, thank you very much.
Great.
Please take it away.
Sounds good. Thank you, Tony. All right. Well, as Tony stated, this webinar is about integrated estimating as a solution to support open BIM estimating workflows. So a version of this was given about a year and a half ago, as he stated. And so today we're going to get more into this. We're going to break this presentation into two parts. The first is just a very quick overview of what is integrated estimating. What do we mean when we use that phrase? And then the second half that Alexandra will be presenting is some practical applications about how this has been used. So as we start to see more and more people adopt this workflow, we want to highlight how different platforms are able to adopt this workflow, this framework, because it is intended to be a software agnostic workflow that can be adopted by multiple different platforms. So for the sake of time, I'm not going to share a lot about myself. I'll have a link at the very end of the presentation that you can go to link up with me and find out more. And likewise, due to time constraints, I'm only going to be able to get so far into the workflow itself. So if what is presented on the first half is of interest, then there will be a link to some more information there as well. And I'm always excited to talk about this. So if you want to reach out to me directly, I'd be happy to chat with you. So there are three goals for this presentation. The first is just to help differentiate why the integrated estimating framework, as we're calling it, is different from traditional model-based quantity takeoff practices. And I use those words strategically. So model-based quantity takeoff practices as compared to what you might have heard as model-based estimating. So why is it different? I'll get into that. The second goal is to elevate and promote integrated estimating as the clear solution for our industry to adopt going forward. Part of that is because it's software agnostic, but part of that is because it gives us a framework and a standard that we can all adopt and advance. And then demonstrate how it is an open platform. From a workflow standpoint, it's not dependent on any particular vendor or software platform, but rather can be adopted by multiple different platforms. So why is that the goal? Well, I'm going to make a bold statement. I believe that integrated estimating is objectively better than what we would call traditional model-based estimating or model-based quantity takeoff practices that we find out in the industry today. I think most people in the pre-construction world who have done model-based estimating will agree and understand what I mean by currently we kind of take an ad hoc strategy to the process. We never quite know what we're going to get when it comes to the model being provided to us from a design team. We never know what the quality of that model is going to be or for what purposes it was really being built. And so what quantities can we really get out of it and trust and that kind of thing. So this workflow does give us a language and a standard to use to collaborate with between the two disciplines. I also think it elevates the role of the pre-construction professional in terms of becoming a leader on the project team and and not just being someone who receives information and does something with it, but is an integral part of that process of developing a model and providing feedback to the design team and the project team. So very simply, let's go through the definition. When we talk about integrated estimating or the integrated estimating workflow, what are we talking about? A simple definition that I'm finding is working pretty well is that it's a framework for model-based estimating. It's built on 5 very specific characteristics. These characteristics were created to distinguish integrated estimating from every other or any other model-based estimating process, because it's designed to address some of the challenges we have experienced over the last, 10 to 15 years if you've been doing model-based estimating in the industry. And it sets forth some clear expectations for how design or architecture and engineering can collaborate with a pre-construction team using a model. So this is focused on pre-construction. Obviously, our industry colleagues that deal more in the virtual building space, that's kind of a different area, but these all definitely work together. And the integrated estimating workflow can be something that's adopted across the board. So historically speaking, we've had some barriers to adoption around model-based estimating. Oftentimes, you'll hear pre-construction professionals say, well, the model's not complete, so I can't use it. And so they set the model aside and miss opportunities to get value out of the model. Sometimes they'll say, well, I've got a model, but it's really poor quality, and it's hard to make sense of what's in it. And so there's just a general lack of trust in what can I trust that's going to come out of this model that's not going to get me into trouble. There's identification and classification issues around understanding what it is I'm looking at. Oftentimes I'll use the example around a box of Legos. So everyone probably typically remembers when they were a child and they had a box of Legos, and they would get something and they would create it by the step-by-step instructions. And then when they were done playing with that particular thing, they would break it apart, put all the Lego blocks into a box. And then one day in the summertime, they'll wake up on a Saturday morning, dump that box of Legos out on the floor. And what's the very first thing we always did? We started to sort the blocks into sizes, shapes, colors, so that we could build something from that. That's kind of representative of what's happening today. We get this BIM, and because it lacks some identification and classification issues, it's kind of like a box of Legos, and we have to figure out what we can do with the information. Another barrier is around a lack of estimating standards. So traditionally, I think we can say that the process for the industry has just been to deploy whatever strategies we can, and that's where I get the ad hoc nomenclature from. There's a lack of modeling standards. Our design teams don't know what to model for pre-construction purposes. And historically speaking, when we think back to the earliest days of model-based estimating, that's probably where the process fell apart immediately, is as soon as we, the pre-construction discipline, realized we could estimate from a model, we could get quantities from a model, we turned to our design partners and said, hey, if you'll just do all of these things, we can get a good estimate from our model. And the design team understandably looked at us and said, I don't get paid to do all that, and that's too much. So what we're asking our design teams to do has to be well within their scope and capabilities. And then finally, and I think really the most important thing is, historically speaking, the platforms haven't allowed us to link the cost item in the estimate to the model object itself. And so that's resulted in a manual transfer of the quantity data, which is prone to error and creates problems. So the integrated estimating workflow has identified 5 major characteristics that help to qualify what is the integrated estimating workflow. And so as you encounter other model-based estimating workflows, you ought to be able to test it to see if it meets the 5 characteristics. Of the 5, 2 are really dealing with the model authoring phase of the process, whether that's a pre-construction person building a model for estimating purposes, or whether that's receiving a model from a design team. The last 3 are solidly in the cost estimating or pre-construction phase of the process. I won't go into great detail on this slide, because I'm going to talk about each one very quickly. And then again, if this is of interest, there's more information out there available. So the first characteristic is around intentional model authoring. What do we mean by this? It means that when I'm the model author and I'm creating content in the model, everything I create, I'm doing so with the knowledge that somebody else is going to consume this model information and attempt to do something with it. They're going to use it for analysis. They're going to use it for 4D scheduling. They're going to use it for class or coordination or estimating. And so I want to be cognizant as the model author of what I'm building, and that it's not just going to be used by myself for design documentation. A practical example of this is this image on the screen. This model was created with great intentionality. It's clean. It can be broken up into its different parts. So this particular building has 3 kind of functional areas. It's got a multifamily component. It's got a hotel or hospitality component. It's got a parking structure. And because it was modeled with intentionality, we could break that model apart in very clean ways and understand what's going on. The second characteristic is around qualitative and quantitative model data. This characteristic says that every object in the model, now that's been created with intent, needs to contain information that allows me to identify what it is and where it exists in the model, and then the ability to quantify it or measure it. So from a very practical standpoint, the qualitative side of this characteristic is around identity information. When I select on a model object, I need to know what is the functional component this model object is associated with. In this case, there's a floor slab, an elevated floor slab highlighted in the model, and it's tied back to this functional component notion called office tower. The assembly code is analogous to simply uniformat. So what building system is this model object associated with? In this case, it's associated with the floor structure of the building, also known as B10. And then the type name, what is this thing? When I look at this model object, I ought to be able to identify what it is by just the simple naming of the object itself. And so in this case, it's called a concrete flat plate slab. So that's really the qualitative side of the equation. And then the quantitative side is saying, I should be able to measure or quantify this object. Now, most of the time, this is going to come from native properties in the model object itself, things like area or perimeter. But for some unique objects, we may need to build in measurable information. So that goes back to the intentional model authoring aspect. And by the way, each of these characteristics builds on themselves. You can't achieve 3 without 2. You can't achieve 2 without 3. The third characteristic is this idea of integrated cost. This is the expectation that regardless of the platform you're using, you need to be able to demonstrate a digital link between the cost item itself and the model object that it's associated with. So right out of the gate, this will eliminate some platforms, unfortunately, from being able to achieve the integrated estimating workflow because they don't provide this ability to link. But this is important. And this is also where the framework itself gets its name. And I like to kind of use the analogy, it establishes a level of integrity or a chain of custody between the cost estimate and the BIM that we're working with. Because there is this digital connection that we can test, we can verify. So here's a screenshot from one application that I use, and Alexander will show others of different applications. But in this application, I can digitally trace back from the line item of cost in my model to where I got that particular quantity from. So as you can imagine, working with the design team or a client and them wanting to see some transparency behind our cost estimate, where did you get that quantity from? We can show it very easily using the model. The fourth characteristic is this idea that we've created an estimating standard that we can utilize in all phases of the design process. This characteristic was created specifically to challenge that idea that, well, the model isn't fully developed. It's not a DD level model. It's only a concept level model or whatever. This gives us tools to work with the model at whatever LOD it is. And of course, not models are comprised of varying LODs, of course. But this helps to eliminate this ad hoc approach. Well, I don't know what I'm going to get, So I'm just going to do whatever I can do, and that becomes this ad hoc strategy. Hopefully it's understandable that an ad hoc strategy is not a scalable strategy. It's not something that can be replicated with consistency. So an example of this characteristic is that the standard has three degrees, I guess you could call it, three ways of quantifying information in a model. The first is the easiest to understand because it's so real. It's a virtual representation of the building object that exists in the model. So here we've got an image of a footing, and it's been so well developed that it actually has rebar showing. This is an example of a model-based estimating standard. We can pull quantities directly from this object, and they are related. They are virtually, literally related to the object itself. Other times we may have less developed models, but we can get realistic quantities from the information. So the second category is called model informed. It basically says I may have an object that is related to the scope of work that I'm estimating, but it's not a virtual representation. In other words, I'm going to have to use this object to inform the quantities that I'm doing. So here's an example of a generic wall object, exterior wall object on a building. It hasn't been divided up into the unique fenestration elements of glazing and solid materials, but I can take the overall quantity of this exterior wall object and break it down into percentages of materials based on ratios. And so that wall object area is informing my exterior envelope quantities. And then the third category, which is probably the hardest to understand for those that aren't involved in this process, but many estimators do this all the time, and they just may not have had this particular language to define it. But model inferred is the third category. And this says that there may not be an object in the model that directly corresponds to the scope of work that I'm estimating, but I can use something in the model to help infer from it quantities for this particular scope of work. So for example, in a very early conceptual model, I may have a grid system laid out, but no column is particularly identified as defined model objects. But I can infer column quantities from these grid intersections that are defined by the grid system. So that's an example. And then finally, the fifth characteristic is the idea that we must be able to apply some level of automation or even augmentation to the process. Now, this is critical because as we look to try to increase the efficiency of the industry, we can't do that unless we start to bring some type of automation into the process. And of course, as we know about machine-based learning and things like this, there needs to be a kind of a standard level of consistency in the data that we're consuming or we're producing in order to be able to maximize the benefits of an automated process. So the fifth characteristic is the culmination of the four that came before it. We have great examples of this in reality today. Many platforms have automated change management platforms that will allow you to take a newer version of a model, compare it to the changes that occurred over a previous version of the model, and then apply those changes to your cost estimate. So that would be one example of an automated process as part of the integrated estimating workflow. Another one that I don't think has been developed yet by any particular software platform, but would be the idea of pre-mapping cost items in an estimate database to model objects in a model object library, such that when a slab on grade is imported into the cost estimate and the system recognizes the type name and says, oh, that's a slab on grade, I have a cost for that. Automatically assigning that cost is a great example of something that might be available in the near future. So what? Why does all this matter? And what does this really mean? Well, I'm excited because, as Tony mentioned, I presented on this about 1.5 years ago, and it continues to just prove itself out to me on a daily basis that this is a great workflow and it's something the industry can rally around. It's also proving each month to be a truly software agnostic process, as Alexander's going to share from his perspective, a totally different platform that I have not used. And we've talked about doing some collaborations on that front as well. So this is a scalable framework that's good for open BIM workflows. It also codifies that all-important digital link between the model object and the cost. This is really the thing that distinguishes this from any other model-based estimating process in use today. And finally, it gives us terminology to help distinguish this. So many people on the call are probably familiar with the term 5D. 4D, 5D, these are terms that started to evolve as BIM started to take hold of the industry in the 2000s. But 5D is a very loose term, and some would argue it's not really an appropriate term. It may be kind of a kitschy term. And so this integrated estimating name gives us something that we can stand behind and use to define process in the industry. So in theory, what the integrated estimating workflow does is it increases the level of quality in a model. And many of you may remember back in grade school getting a worksheet as you're learning your vocabulary, where it has an image of something on the left-hand side and then the corresponding word on the right. And you literally draw a line between the object or the image and the word as a way of connecting the dots and learning vocabulary. This is really what the integrated estimating process feels like in practice. You've got these model objects that have a great level of quality. They're very intuitively understandable, and you're drawing the line between the model object and the cost item in your estimate. So you can see the potential of where this goes in terms of improving efficiency and accuracy in the industry. But that's in theory. In practice, though, I am learning each month that this workflow is really strong. Probably even more than 80 projects, but definitely 80 projects to date, just for me and our team, not to include what Alexander and Veljko are doing and many others are doing in the industry. We're seeing some success with this. We're seeing a lot of success with this. And we're seeing it in the areas that are around comprehension of the design model, of the design intent behind a project. Help me see from your vantage point, architect, what it is that you're wanting to bring to life here. And so when I can see that model and make sense of it because of the great organizational structure in the model, that helps me as an estimator or as a pre-con professional give you more accurate information. It allows us to introduce the model earlier in the design process to the pre-construction process. So rather than developing content over here and then over here on the left, I'm working just in a spreadsheet, kind of in a silo. This really brings us together through the use of the model earlier in the process. It certainly increases efficiency. It's reduced a lot of our estimating labor as a result of this process. The change management features enable us to reduce user error around what's actually changed in the design from version to version. Probably the thing I'm most excited about, though, is the ability to use the model to convey cost information back to the project team, whether it's the owner or the design team I'm working with. I get to use the model as the pre-con professional to help convey and communicate cost information. And to be able to say, here's my slab on grade, and here are the various items of cost I've got associated with that model object, really helps comprehension of the cost of the project by people who aren't doing this in their day-to-day work. So I'm going to pause there, and I'm going to stop sharing and invite Alexander to come on and share some practical examples of the integrated estimating workflow using their process or using their platforms. And then we'll come back and finish up at the very end.
Thank you very much, Mr. Pilgrim. I'm going to start sharing my screen. I hope you can all see my screen. Hello, everyone. My name is Alexander Ilic. I'm a senior BIM manager at BEXEL, company and product owner in development of BEXEL Manager software. Today, I will try to present some practical examples of the Mr. Pilgrim's framework. I mean, the first time I was reading his paper, I was just amazed how much it is in line with our vision, our point of view on estimating, and how our workflows are actually in line with his framework, which definitely proves how platform independent or vendor neutral the whole approach is. So I would like just to go through his 5 principles and try to present some of the of the actual workflows that we are using on every project from day to day, and also our users all around the world that are in line with these 5 principles. So the first one, let me just, okay, it's working. When it comes to intentional model authoring, from our experience, the biggest problem was that people who were just delivering the models that are not of the sufficient quality is that they were not aware of the certain mistakes they were making. Simply in authoring tool, they were not able to visualize how the data they are actually inputting and creating in the model is affecting the work of the people that are actually taking over that models and use it later. For example, we received many times the models where you have elements that are placed in one level and they're actually assigned completely different levels. So that's something that you hardly could understand and see in your authoring tool. So we try to develop workflows, mainly data visualization and control tools, so that you can actually visualize your data in the BIM management software, so that you can see all of these, you can visually see if certain element of certain a level is simply in the wrong place, so that you can understand where the mistake is, so that you can understand how you should change or update your project in order to be in line with this. And this helped a lot. I mean, when you present to people, okay, the problem is because this particular element is not of the appropriate category or type name, or this particular element is in a wrong position, so it breaks the spatial structure of the model, and people understand how impactful this could be on the later stages of the project. Then, of course, after this first stage, you come with probably the basis of every workflow, especially estimating, but basically every BIM workflow, which is qualitative and quantitative model data. And again, I think that the biggest opposition from the people who are preparing and creating the models is due to unclear requirements. When you set up requirements in the right way, when you set up your information delivery specification, and when they know what they need to deliver, what is the format of the delivery, what are the properties that need to be populated, it is much easier to communicate, to collaborate with people, and to get what you need. So to get your qualitative data, to get your quantitative data organized in a proper way. But then we come across another challenge, and that is how to control the quality of this data. Especially on the large scale project, you simply have too many data, too many elements to go and manually check if every certain element in the model contains every property. Then when you figure out that the property is there, is that property named correctly? Is that property in the correct property set? Is the type of the property correct? Because you could have length or volume that is text property, which is useless for the cost estimator because he simply cannot summarize textual properties, even though it is written in the numbers. So we solved all of this with an automated data check workflow, which is supporting IDS standard, which was officially accepted by Building Smart, I think, a few weeks ago. So where you have ability to set up your information delivery specifications, but also to take this checklist directly into the software and to get the result automatically, to simply and in an efficient way visualize which elements are lacking which properties, where are the problems in the model data sets, where the model layers should be improved, and in that case you could then in a very good way assess and visualize the health state of the model, and then you can make sure that the model is in the appropriate state for the next stage of cost estimate. But of course, even with all of this, it happened to us on many projects that you still have to populate additional properties. Simply, certain property sets are something that designers simply don't know in this phase of the project where they are actually creating the model. So there are certain sets of properties of data that needs to be added later. So again, the question here was, Of course, you can have a manual input, so you can simply select the elements, classify them, add additional locational properties, classification properties, but that is again very time-consuming and inefficient way of doing it. So again, we came back to the automation of this process by simply allowing users to specify the templates for data enrichment, as we call it, where you could rely upon the existing property sets in the model and add new layer of properties by simply referring to the existing properties. Because more or less every BIM model in the world contains a very robust layer of what we call systemic properties. That means the category or IFC entity, let's say, the system group name, is it structural or not structural, story elevation. So there's set of properties, building name, especially in IFC schema, which are by default inside the model. And many of the relevant and important classification properties could be attributed to these elements following just the combination of the properties that are already in the model. So for example, if you have the IFC wall that is structural, then you can very easily make a conclusion that this specific wall should be in a classification category for structural load-bearing walls. So when you set up such templates, then every model, even if it's not 100% ready for the estimating workflow, could be very easily populated and mapped with the classification system that could be utilized later for the model-based estimation. Of course, this could be, from the assembly codes, the basic classification properties, to the functional component location, to even, we use it, let's say, for the reinforcement density population from some Excel tables that were produced by the structural designer that were completely outside of the BIM, but simply they could refer to the certain type of the element, let's say a column with a certain mark, that should be attributed with a certain property that they already calculated when it comes to reinforcement. And then we can simply, using this system, integrate this non-BIM set of properties that is crucial for the BIM workflows associated with the BIM elements, and use it further in our workflows for the BIM-based for the model-based cost estimation. When it comes to integrated cost principle of the framework, again, we are completely in line with this approach to the cost estimation in BIM. Definitely, every cost item, every description, every line item in your cost classification could be to a certain way attributed and directly linked and connected to the model elements. How we solve it and in which way we related it is that we are using, we call it element query. We could call it a filter. So it's a basic rule that will specify which elements with which property should be attributed or linked to that specific cost item. So it could be as simple as, cost item A1010.10 should be attributed to all the elements that contain assembly code A1010.10. If you have the model with the enriched data layer, that could then very easily be mapped from the coding system of your classification and the elements itself, or it could be much more complex query, much more complex filter that will say this is the element that is of category wall, which contains certain phrase in its type name that is specified, that is placed in a certain elevation, and so on. So you could, in a very detailed way, specify this connection, this link between your model and your cost item. And what is the main advantage of this is, first, that you can very easily relate the information that you see in your budget when it comes to quantities and budget with the elements that were actually taken into account during the calculation. And with every change, and we know that at least one thing is for sure on any project in the world, there will be changes. No matter in which phase of the project you are, there will be always changes and updates. When you do changes, when you do updates, you're gonna then very simply update your cost classification and keep it relevant. Another side of it, so one thing is that we need to relate elements to the cost item, cost description, cost name, cost code. We also should provide calculation of the item's quantity based on the quantitative data that is mentioned in Mr. Pilgrim's paper, so that your estimation quantity is also tied to the model elements, and that with the change and modification of the model, your quantities and your calculation in your budget is changing as well. And of course, once you assign this cost estimate to the model, another benefit is that simply you could share this with other stakeholders, and then you have reliable source of information, since everybody who simply clicks or selects certain cost item, certain cost definition within your budget could know for sure which elements were in the calculation. So everything is transparent. Then if we go to the estimating standard principle of this framework, again, we're completely in line with how it is described in your presentation. So yes, the system needs to be robust. It needs to be applicable no matter if your model is LOD 200, 300, 350. You should be able to calculate with a reasonable precision your quantities to the model, even if its level of development is lower or is not on the highest level. Why is this important? Because I mean, creating and developing very detailed model requires engineering hours. Engineering hours are costly. So I mean, this is the business. Let's be honest. This industry works with very thin profit margins, and we have to be very careful with the amount of work and with the return on investment with every new workflow, including the BIM. So we have to make sure and to understand that making the highest LOD BIM models is not always the wisest decision, because simply investing additional engineering hours into something just to get the improvement in, let's say, accuracy of a negligible percentage will just reduce the productivity and usefulness of this technology. And that's why you should, I would say, pick your battles very well. So you need to model to a certain level of detail the elements that are the most costly, that are most prone for the possible mistakes, and that are most risky for the execution. On the other hand, you should probably reduce your detail level for everything that is not as important for your for the construction, that could be calculated, as the paper infers, you know, by inferring to certain model elements that already exist in the model, that could give you a reasonably accurate picture of what you have on the project. So the first example is, of course, simple, when you simply relate your cost calculation directly on the quantitative properties of the presented element. So when the element is 100% accurately represented as it is in the construction site. But that on another example, let's say in this case that we're showing the reinforcement of the concrete slab. Of course, the most straightforward approach would be that we model the reinforcement in this case, but it is questionable. Do you have resources, do you have expertise in today's construction industry to supply enough people with modeling skills to the companies to model reinforcement, which is very challenging task for every single project in the world? I would say yes, if you're building the bridge, maybe it's a wise decision to model the reinforcement, because the reinforcement in a concrete bridge is probably 40% of the price, and there many additional risks that are not related to the pricing and estimating that imply that you should model these elements in a such engineering structure. But on the other hand, on a regular high-rise building, residential building, it is probably not wise to model to the latest detailed reinforcement. You could simply use a model-informed approach, where you could simply, you know, rely upon the concrete element, which will contain in reality this reinforcement, and simply populate additional property, which will be reinforcement density for that specific element. In most cases, that is already calculated by the structural designers. This information is almost always available somewhere in the design documentation. Now we have the workflows that could automatically link or connect that information with the model elements, and then we could simply calculate to the reasonable extent accurately the quantities of reinforcement in this case by simply multiplying volume of the concrete element and the reinforcement density of that concrete element. And you're going to save a lot of engineering hours. You're going to have ability to map your cost pretty accurately, and to make sure that the quantities of reinforcement will be updated with the project update. And still, you're going to have very decent estimation, and you're going to rely upon the model that is not, I would say, 100% accurately modeled to a high degree, high level of detail. And the third principle, which is again very useful, especially in the pre-construction phase, especially in the concept phase, when you simply don't have enough time, knowledge, and resources to model everything to the last bit, where you could simply, model informed approach, where you can simply link your cost data to the specific element that doesn't represent that scope of work, like in this case, electrical service distribution. You simply distribute it by spaces. So you simply have the statistical data, especially in the pre-construction phase, of how much these specific low voltage cables you're going to have per square meter of certain type of the building. And then you can simply map your cost data, your estimate, to the spaces. So you would have much more robust system than if you simply go and calculate it manually, because no matter how good it is and how precise it is, with the first update, it's going to crash completely. So if you simply specify it to a certain model element, like in this case, spaces, you're going to have very robust cost estimate that will evolve and work with your project update. Of course, in case that in the later stages of the project, you actually decide to model certain systems, you could always switch the element query or this linkage system to the new elements that will give you more accurate, precise estimation. But this is very good tool that will help us to overcome the challenges that Mr. Pilgrim mentioned, of undeveloped model, underdeveloped model, the model in the pre-con stage that still could be very useful for the cost estimates. And of course, the fifth principle, which I would say is something that is completely connected with all the previous four principles, and which could be probably implemented in every stage of the project, in every of these previously mentioned principle, is automation. So because a lot of these workflows, the challenge is they require a lot of manual work and a lot of repetitive manual work that people particularly don't like. We were trying in the past, and we are still trying and improving and trying to automate as much as possible of these repetitive tasks, and to leave the room for the more creative work, for the work that brings more benefit to the project. So if we mention some of the automated workflows that we actually developed following these previous principles, so we all have already mentioned automated data check, automated data enrichment processes, where you can simply specify the template and then use it on every new project to automatically populate data or to check the quality of your data. We also support automated cost classification creation, which I'm going to present with a short video after this slide. Then we also jump to the next level. So after the estimation, we see the value of this framework and the possibility to extend it even to the scheduling and planning process, because once you have good, reliable estimation process, you can build upon it a very good planning and scheduling process after that, and ensure huge benefits for the project even after pre-construction phase in all the following phases. We're also working on an AI assistant. We have just released the beta version of our AI assistant that will additionally improve and help you to simply bridge this gap between the computer language that is used in every software, including ours, to simply describe certain workflows and the written language that we as humans use in order to describe what should be done. And of course, automated reporting, which is essential because no matter how good estimation or how good progress tracking you do, if you cannot automatically export reports and present it to other people, then they are not of much use. So as I said, the data check, we already walked through this process of automated process where you can simply specify in a template your checklist, then import it to the software, and then the software will automatically go through the elements and simply organize the elements into BCFs with the comment which properties were not properly applied to this specific element. Data enrichment process, which allows you to even a half-prepared model, to enrich it with, in this particular case, cost classification data. So to basically get it to this stage where it is a Lego, where it is a classified Lego, where you know where it is classified by color, by size, and so on, so that you can start assembling this model into useful analysis that you need later. Quantity takeoff, of course, automated quantity takeoff is also another level of automation that we introduced that allows you that once you populate this classification data and once you practically sort or break down your model by this familiar system, in this case uniformat, that is not limited to uniformat, it could be any classification system, including the custom one used by certain customer. You can simply then organize the model, and you can from the model breakdown create the cost classification directly. So you can create work breakdown structure directly by organizing the model by the codes that are populating inside the model. And then from this work breakdown structure, you can then simply create the cost classification, which has its own resources, which has its own links or rules to connect model elements with the cost items, which has its own quantification rules, and so on. So this is a short video showing this process and how we envisioned it in our software, how it works in BEXEL Manager. So practically, you first create the work breakdown structure by using, so just to understand that these codes were populated using automated data enrichment process. So we associated the uniformat codes with the particular elements in the model. So now we have the elements that have this description, classification description, so that we can easily identify and sort them into groups. Based on this, we create work breakdown structure that is following uniformat hierarchy. And then based on this work breakdown structure, we are automatically creating cost classification. How we do this? Again, using the knowledge templates. One of the templates is that we could just prescribe for every possible code of uniformat classification, we can say which name and description should be associated with that particular cost item. Then we can prescribe the rules of measurement. We can say, okay, if the model is with these specific properties, it should be calculated in this way, so that we can take advantage of the quantitative data that we have in the model. And then with this, we can create cost classification automatically and get it right away linked with the model elements. So you can see the element query, which is automatically created. And then you can even use this cost classification, in our case, export it to Excel and populate the prices. Of course, the prices are something that need to be populated, that cannot be determined by the software itself. And then once you do this, and once you assign cost classification, once you specify the rules of measurement, how your model elements will be calculated inside the cost classification, you could simply, what we call, auto-assign this cost classification to the model elements. Of course, you first need to check which elements failed to connect to the, which cost items failed to connect to the model elements. There is additional quality control check. And after that, you can simply assign the newly created cost classification with the model and get the estimate that is fully connected to the model elements, so that whatever happens to the model, whatever change happens, you're going to have in the future right away change and update in your cost estimate, and you're going to have reflection of that in your budget. Of course, after this, the next step is that in our case, and I believe this should be also included in other platforms as well, that it would be great if all of this analysis that we create could be then shared using OpenCDE platform. But again, this should be some open format that will allow us to vendor neutral. We share this information, of course, through the cloud platforms, that we are not binded by the software that is installed on premise on desktop, and that we're going to be able to communicate this data through OpenBCF standard between each other, between different softwares, and so on. And what I here labeled as a sixth principle, but which would be, let's say, our proposal for the future development, is how this model-based estimate could become a precondition or the basis for the optimal planning process and execution. So how this works, what is our idea? So in case you did a model-based estimate in your model, and you have the cost items clearly defined using some classification system, then more than half of your work for the planning is done. Because if you look at the planning process in general, it is basically assembled from two main processes. One is spatial project organization. That means that in your schedule, you need to simply reflect the spatial organization of your project. So if you have two buildings, you're going to have two master tasks for building one and building two, and you're going to have sequence between them. If you have 5 floors on these two buildings, you're going to have 5 subtasks in both of these parent tasks for every floor, and you're going to have finished start relationship between them. If you have phases on every of these floor, you're going to further go and just make it more detailed and make every phase on every floor. And that is, I would say, easier part of the scheduling. The tougher part is the work sequence definition. And that is conditioned by the technology of execution, by the typology of the project, and in general location and specific conditions on site. But this methodology, we believe, should be tied to the classification system that is used in estimation. Because why would be in planning inventing something new to describe groups of works if we already did it in estimation? You know, if in estimation we specify that this is standard foundation, if we specify that this is site cleaning process, if we specify that this is concrete floor, or this is concrete column, we should simply refer to those concepts that are already in the cost estimate and simply specify relationships between them to create the schedule. How we do this in our platform, we automated this process, and we separated it into zones and methodologies. Zones are defining the spatial, the sequence of spatial units of your model. That means building 1, finish start, building 2, and so on. And methodology is a work sequence where you simply refer to the groups of works in your cost estimate that is already integrated with the model, and you specify the sequence of execution. So in this simple example, we would just say, okay, we're going to find groups of works foundation. It's going to be finished start relationship between foundation and slab on grade. It's going to be another finished start relationship between vertical load-bearing structure and slab on grade, and then we're going to go with the horizontal load-bearing structure over the vertical. And we're going to repeat this sequence on every floor, in every building, and probably in every future project of the same typology. So instead of every time going and creating schedule from scratch, we're going to define this methodology, this logic of project execution that is relying upon estimation, that is already organized into classification system, that is the common language that we could all understand. And in every future project, I could simply reuse it, and I can get the schedule with few clicks, basically using this system. And it's pretty versatile. We use it on very, very different types of projects, from the large scale projects to the small projects, from the stadiums to infrastructure. So all of these were very easily applicable with this system, because simply you rely upon something that is a common language, something that is pretty robust, something that very clearly is connected to the model elements, and something that is going to be consistent even in the future projects, because it's relied on a classification system that is a common language for everybody. So at the end, all of this together is forming one integrated workflow where you can automate a lot of these processes, maybe more of them in the future, but where from the beginning, from the pure IFC, just relying on the data that is already inside the model, and with this flexible system that could relate even to the model elements that are not developed to the highest standard of a level of detail, you could create first enrich the model, create the cost classification or the pre-construction estimate based on it, and then base the planning and automate the planning, since you have this very good basis, the estimation that is connected to the model. Of course, after that, then I mean the sky is the limit, because when you have such an integrated system, there is huge data pool that can be used for various key project indicator analysis, various dashboard that could give you a basis for the informed decision for the future as a project manager, and that could simply give you the basis for good and reliable execution of the project. So yeah, that would be all from my side. Thank you very much for your attention.
Well, that's exciting, Alexander. It's cool to see other people having such great success with the framework and applying it in their
Thank you.
in their environment. Can I switch over to share my screen for
Yes, let me just stop sharing. Yes,
yeah,
please.
so Alexander has provided some great practical examples of the 5 characteristics. You can see those in practice and how they actually play out in the real world. So that's exciting. One question might be, where do we go from here? And I would argue Veljko and Alexander are demonstrating where we go from here. If we think of the integrated estimating framework as the underlying foundation from which we can build practical solutions on top of, they are demonstrating that. So the integrated estimating framework can serve as the what and the why, and then we need the how of the process. How do you actually implement and execute this, which he has shown very, very well. I did want to highlight that with the BIM Forum, we've developed an estimating with BIM guide, and this is a practical implementation guide on how you can do this. It's a work in progress and will continue to be developed. You may be familiar with the Plannerly platform, and Limson Consulting and Ross Griffin with Cosmos have come up with a methods of measurement implementation strategy inside the Plannerly platform. And there's a host of others that are pursuing this kind of implementation strategy, where I think the BEXEL example is a very specific one that is another great example. So just to bring this to a close today, that was exciting. It was great to see all those examples, Alexander. If you're interested in connecting with me, I didn't share much about myself. There's a link to my LinkedIn profile. If you want to read, Alexander referenced the paper. There has been a peer-reviewed research behind this integrated estimating workflow that's available with the second QR code. And then, Tony, I will hand it back to you to bring us home.